Hey everyone, welcome back to the Cyber Tutor channel. In our last video, we explored hashing algorithms like MD5 and SHA-256 and how they're used to secure passwords and data. Today, we're taking it one step further with something called salting hashing. This small but powerful technique is a game changer for password security and protecting sensitive data. So let's break it down. What is salting and hashing? Hashing by itself converts data, like a password, into a fixed-length string, a hash. But here's the problem. Attackers can use pre-computed databases like rainbow tables to reverse engineer common hashes and guess weak passwords. That's where salting comes in. A salt is a random string of data that gets added to the original password before hashing. This makes the final hash unique, even if two people use the same password. For example, if two users both choose the password cyber123, without salting, the hash will look identical. But with salting, the system adds a random salt to each password, so the hashes are completely different. How salting works. Here's a step-by-step breakdown. A user creates a password. The system generates a random salt. Think of it as extra seasoning added to the password. The password plus salt are combined and run through a hashing algorithm like SHA-256. The final salted hash is stored in the database, along with the salt value. Now, even if attackers steal the database, they can't simply look up the hash in a rainbow table because every salted hash is unique and unpredictable. Impact on cybersecurity. So why is salting so important for cybersecurity? Defends against rainbow tables. Pre-computed hash databases become useless because the salt makes every hash unique. Prevents hash collisions in passwords. Even if users have the same password, their salted hashes won't match. Adds a layer of complexity for attackers. Brute forcing becomes slower and more resource intensive. Improves data protection. Even if the hash database leaks, attackers still face a major barrier before they can crack the passwords. This technique is one of the fundamental defenses in securing authentication systems. Example, attack scenario. Let's say an attacker steals a company's password database. Without salting, if 50 people all use the password 123456, the attacker only has to crack that hash once to get all 50 accounts. But with salting, each of those 50 accounts has a different salted hash, meaning the attacker has to crack them individually. This massively increases their workload and lowers the chances of success. Why cybersecurity students need to know this? As a cybersecurity student, you need to understand salting and hashing together because they're the foundation of modern authentication. You'll see them used in databases, login systems, cloud authentication, and even APIM. Many breaches happen because organizations fail to salt their hashes. Learning from those mistakes is key, and when you're working in security, auditing systems, or penetration testing, you'll need to check if proper salting practices are in place. In short, salting is a simple but powerful defense every security professional must know. Final thoughts. So to wrap up, hashing secures passwords, but by itself, it has weaknesses. Salting adds randomness, making each hash unique and resistant to attacks. Together, salting and hashing are the backbone of secure password storage. Remember, as future cybersecurity professionals, the little details like adding a salt can be the difference between a safe system and a devastating breach. Thanks for tuning in to this episode of the Network Fundamentals series. If you haven't watched our last video on hashing algorithms, check it out first to get the full picture. And as always, don't forget to hit like, subscribe, and share this with your classmates. Stay informed, stay vigilant, and stay secure.